The AI revolution is running on a totally new kind of engine. But we're not talking about just servers in a warehouse anymore. These are massive, power-hungry AI factories. So how on earth do you actually build one? Well, today we're going to look at the master blueprint created by none other than NVIDIA.
Right, so forget everything you think you know about traditional data centers. We have moved way beyond simple racks of servers. We are officially in the era of the AI factory, a whole new kind of industrial facility built for just one purpose: to generate intelligence on a scale we've never seen before.
But here's the thing. Building these factories is a monumental challenge. And I mean, it's unlike anything the tech industry has ever tried to tackle. So what exactly is an AI factory? Well, at its core, it's a data center that operates at gigawatt scale. We're talking about the same amount of power as a small city. But it's so much more than just raw power. It's this incredibly complex ecosystem where hundreds of different companies, from construction firms to cooling specialists, all have to work together, perfectly in sync.
And the problems they face are just immense. You've got these insane power demands, mind-boggling physical complexity, and, frankly, the logistical nightmare of trying to coordinate hundreds of partners. But you know what? The biggest bottleneck has always been this fundamental disconnect. The people designing the building have almost never worked with the people designing the computer chips inside it. At least, not until now.
So how do you solve a coordination problem that massive? Well, NVIDIA's answer is a master plan, a kind of universal blueprint for everyone. It's called Omniverse DSX.
Now, DSX isn't a product you can just buy off the shelf. The best way to think about it is like a master recipe. It's an open guide that brings every partner and every single stage of the process together, from the very first sketch on a napkin to the moment you flip the final switch.
And this quote right here, it gets right to the heart of it. For the very first time, the architects and the chip designers can literally work in the same virtual space. They can see in real time how changing a single cooling pipe might affect GPU performance, or how a new server layout impacts the entire power grid. This co-design idea, that's the real breakthrough. Okay, so that's the big idea, but how does this blueprint actually work in practice? How does it turn this super complex vision into a functioning gigawatt-scale factory? The entire process really boils down to this three-step life cycle. It's pretty straightforward. First, you design and perfect everything in the digital world. Then, you build it efficiently in the physical world. And finally, you use a digital brain to constantly optimize its performance once it's up and running. It all kicks off with this incredible concept called a digital twin. Just imagine a flight simulator, but for a data center. It's a completely virtual, physically accurate model of the entire factory before a single shovel ever hits the ground. Every pipe, every server rack, every power line is simulated down to the last detail. So inside this virtual world, you've got everyone collaborating. Engineering firms are optimizing the layout. They're using these pre-made digital models of real equipment from partners like Siemens and Schneider. They simulate everything: the heat, the power flow, the airflow, and the ultimate goal is to squeeze out every last drop of performance, what they call token generation, for every single watt of power being used. All right, so once that digital plan is absolutely perfect, we move to the build phase. But instead of your typical slow construction, this is more like building with high-tech Legos. Partners deliver these prefabricated, factory-tested modules that are basically ready to be plugged in on site. And as you can imagine, this modular approach just dramatically shrinks the build time. Now, this is crucial. The digital twin doesn't just get thrown away after construction. It actually becomes the live operating system, the brain, of the physical factory. AI agents, which were trained in that perfect virtual world, are now monitoring the real facility, making constant, tiny adjustments to optimize power and reduce strain on the electrical grid. It's amazing. So we've seen the life cycle, right? But what's the core technology that's making all of this possible? Well, it really comes down to three key pillars of the DSX architecture. The whole system is built on these three pillars. First up, you've got DSX Flex. Think of it as a super smart energy broker. It's constantly talking to the power grid, drawing power when it's cheapest and cleanest, which is a huge win for sustainability. Second is DSX Boost. This is basically a turbocharger for your GPUs. It fine-tunes all the internal workloads to squeeze out up to 30% more performance from the exact same hardware. And finally, there's DSX Exchange. This is the universal translator. It's the data fabric that connects all the different systems, letting them talk to the digital twin for seamless total control. Okay, this is some seriously fascinating technology. I get it, but what does it all mean in the real world? What's the actual bottom line impact of building AI factories this way? Well, the impact is measured in billions with a B. By building faster and running more efficiently, a single one of these AI factories can generate billions in additional revenue. But honestly, it's not just about the money. It's about accelerating the future. Getting these incredibly powerful tools online months or even years ahead of schedule completely changes the pace of AI innovation for everyone.
So to sum it all up, the DSX Blueprint directly solves all those huge challenges we talked about at the beginning. It gives us a scalable architecture, it maximizes efficiency, it dramatically improves sustainability, and maybe most importantly, it just accelerates the entire process of bringing a new AI factory to life.
And that really brings us to a final, crucial thought. The blueprint for these AI factories, it's here. The very foundation for the next wave of intelligence is being laid right now, as we speak. So the real question isn't just how we build them anymore. It's, as they come online faster than we ever imagined, what will we create with them?